Welcome to all. This is part 4. You can make a note. Part 1, part 2, part 3. I have given all basic requirement for analysis of doubly line post sections for given cross section by demonstrate method. So, one example. Now we are starting actual example or numericals, or some people will tell problems will start now. Examples for finding ultimate MR of doubly line post rectangle section of given. The given is very important. Why? Whenever the word given is there, it is analysis. Okay. Question 1, A. I will tell what is question 1. Question 1 is exclusively meant for mild steel. You write a note here. It's exclusively meant for mild steel. Actually, practically not that much important. But what happens is, if you study this one, see, forget about those things all. Procedure is same. You get thorough idea when you enter torch steel. So, A. I will go for A, B, C. How many problems required? I told trial and errors will be there. In this question, I will see that your first trial only will click. Question I am setting. See, I have set the question so that your first trial will click. So you will be very happy in this question. But don't be always happy. Luck will not favor you later. So anyway, you follow the procedure given in the previous part. So first thoroughly go through part 1, part 2, part 3, and then only start part 4. This is applicable for all further parts. When you go to part 5, I will tell, including part 4, not only 1, 2, 3, study part 4 also. If you do that way, then you will understand thoroughly. So this I will remove now. So now, okay, I will go to question. Sorry. First, question 1A dictated in the class. Because otherwise it will take a lot of space. Dictated. Okay, start. I will read the question first. Actually, I am not written anywhere. I am seeing the sketch there and reading the question. Okay. Find ultimate moment of resistance for a rectangular section of width equal to 300 millimeter and overall depth equal to 350 millimeter. Subjected to sagging beam. So this you already know. If it is not given also, no problem. Okay, sorry, I should not tell in between. Subjected to sagging beam. Okay. The beam cross section is reinforced on tension side by 4 bars of 25 mm diameter at clear cover of 45 millimeter, and on compression side by 2 bars of 12 mm diameter at a clear cover of 40 millimeter. Take M20 concrete and mild steel of grade FE250. This is a question. Okay, start. So now all you have to do is follow the steps. Solution for question 1A. Write given cross section. These all you already know it. Because everything in working test method, 7-8 times I told. You write all data. D equal, see, this is clear cover. 350 minus 45 minus half of 25. D dash. So I forgot right here. This is your extreme compression edge. Don't ask me why. From there to center of the steel, 40 clear cover plus half of 12 is 46. Okay, now write data. All data required right here. See, first question, I wrote everything. Next time what I will do? I will put waves B, wave D. Means statement you are right seeing the first question. Because space problem will come when you go to trial and error procedure. Concrete over steel Fe250, I told, based on Fy, get XU max by D. Required to find ultimate MR of given cross section. That is the question. 1 minute. So, first one thing I forgot right here, mark here. As usual, neutral axis, I told you, always measured from extreme compression edge, that is your XU. Okay. Now start. First required. First step will be, I will write here, location of neutral axis. Location of neutral axis. Neutral axis, very important. Neutral axis, what? For given cross section. the given cross section is very important. Okay. That is, you can write here. That is, you want to find the value of XU, question mark. Now, one statement you write. There is no place to write here. What? Let XU be, next time I won't tell, depth of neutral axis from extreme compression edge. Okay, then, use your statement. Equating, this also next time I won't write, equating resultant compression force to tensile force. Okay. 1 minute. Oh, here only. That is what you are doing. That is Cu equal to Tu. Equation is 0.36 FCK into B into XU plus FSC, remember, troublemaker, FSC, into ASC equal to 0.87 Fy into AST is the formula. Now, one state, you have to always write what is FSC. Where, right here, FSC is stress to be considered in steel in compression or in compression reinforcement, whatever you want. Okay, right here. Further statement. FSC is to be obtained corresponding to or based on corresponding to strain in steel in compression. That is epsilon SC. Okay, start. We have formula, write directly. Epsilon SC equal to 0.0035 into XU, unknown value. See, XU is unknown there. XU minus D dash divided by XU. Okay. Now do one thing. This equation for epsilon is expression. Now, I told one statement. Last time I told why trial and error required all. That all not required. Refer the class. Just write. See, just write here. XU depends on epsilon SC, comma, which in turn depends, you can write here, back on XU, back. Once again, if you look back side, back on XU, that's all. XU depends on FSC, XU depends upon, FSC, not XY. FSC, epsilon SC later. XU depends on FSC, which FSC, see, I told FSC depends on what? Epsilon SC. If you want FSC, you require epsilon SC, which again in turn depends on XU. Therefore, let us solve by, write correctly, no space here, trial and error method, procedure or method. This statement you have to write. Next time I won't write. Okay, now start. What I told. So, let us initially find FSC for XU. Your XU is there. See, that XU equal to, I told you, you try first XU equal to XU max, starting trial. Later you will see what happens. XU equal to XU max. Or equal to further, we can go further. Equal to, see, XU max by D is 0.53, equal to 0.53 into D, equal to 0.53 into 292.5, or equal to, I already calculated, where I calculated? I have not calculated, okay, It is somewhere calculated there. 155.025 millimeter. This is the initial value. Remember, that is, you can make 1 year. Let us finish a point. You can make statement here. See, trial 1. Trial 1. Okay. Let us space problem. Initially, find. Okay. Trial 1. Now, what you do is, now for this XU, you find FSC. Substituting, we get epsilon SC equal to, now right here, for this XU, you find epsilon SC, then using the format procedure given for you in the previous classes, find FSC. Epsilon SC equal to 0.0035 into XU equal to XU max, 155.025. Remember, this may be correct or wrong, minus D dash. Where is D dash? D dash is somewhere here. 46 minus 46 divided by 155.025. Epsilon SC will come 0.00. I have not calculated because I know that it will come more than elastic limit or proportionality limit. But now you require the value. Okay, I will calculate. 0.0035 into bracket 155.025 minus 46 divided by 155.025. Correct. 0.00246. 0.00246. 246. Now, one note right here. Note. Now, proceed further, referring to part 1 and part 2, where I thoroughly explained how to find epsilon SC, how to find FSC based on epsilon SC for both mild steel and torch steel. Today we have to continue as per mild steel. You write all those things. I told you, unless you thoroughly understand part 1 and part 2 and part 3, you cannot do anything. Proceed further. Right here now. Referring to IS code, figure number 23, I told B for mild steel. For mild steel. First right. We have statement, usual statement. Epsilon SC. You write one statement here. We have strain in steel at proportionality limit, because there is no space to write. You write here. If you are serious, you should write strain in steel at a proportionality limit, or epsilon SC PL equal to mild steel is Fy by 1.15 into ES equal to 250 divided by 1.15 divided by 2 10 to the power 5. That will come, calculate it. 250 divided by 1.15 divided by 2 10 to the power 5. 0.001087. That much accuracy not required. Okay. 0.001087. Are you sure? Let me check it first. 1 nimisha. 250 divided by 1.15 divided by 2 10 to the power 5. 0.001087. 1 minute to explain. 0.001089. Okay, now proceed further. This is the value. I'll do one thing now. To understand, I'll put one more number here, because 0.00, there's a reason for it. 250 divided by 1.15 divided by 2 10 to the power 5 is, it comes to 0.001086 something. Or I'll put one thing, I'll put 87. Okay. Now take this value. Now don't change it. Okay, continue. Now, therefore, I told you, compare our epsilon SC calculated. See, I told you, this is your, that is epsilon SC calculated, right here. Therefore, epsilon SC calculated, that is how much answer? 0.00246 is more than epsilon SC at proportionality limit. How much answer? Answer is here only. Therefore, directly, see, mild steel, if it is more, therefore, directly, Fy equal to, from IS code, just F, not Fy. Therefore, Fsc equal to just Fy by 1.15 equal to 250 by 1. I told last time, in mild steel, if the strain calculated exceeds the proportional limit, directly, it is parallel to baseline. Okay. Our answer is, you already got it. You already got it. 217 point. It is, no, I had to calculate it. 217.39 Newton per mm square. Okay, 1 minute now. Want to check the camera. Sometimes what happens is, go slightly out of camera, it gives you problem. Yes, see, slightly going that side. Okay. Because finally everything should be clear. Okay, now visible. Okay. Now fully visible. Because when you study later, nothing should be invisible. Actually, I am recording daytime, very hot here, and some sound disturbance may be there, but voice will be clear. Okay, over. Now, 279 is over. See now. What happened? You can make a small note here. See, this is a value. Now, with this value, substituting, let us find xu. You write here. Let us find xu from the, you write here, from the expression for neutral axis, that is this equation. You write there. This is, see, we started. To get xu, you require FSC. Finally, some FSC came. Substitute here. Substituting 0.36 into FCK. Where is FCK? FCK is 20 into B is 300 into XU. Space problem is there. I will adjust here. XU. Then minus FSC. 217.39 into ASC. 226.19. Then this answer equal to 0.87 into 250 into 1963.5. Solving, you get the value of XU. XU will come 174.95 millimeter. This is the value of X you will get. Okay. Now, I will not tell again and again. I am going to tell first and last time. See, limit state method, or red color. It is limit state method. This I told you repeatedly. Limit state method. Forget about your trial and error, FSC, etc., etc. As soon as you get XU, you have to first compare it. You should write all these things. If you want, write here. Next time I won't tell. Next time tell limit state method importance. You have to compare XU with XU max, and if it comes under reinforced, continue with whatever you got XU. But if it comes over reinforced, calculated value cancels. You should take what? You should consider whatever is the limiting value XU equal to XU max. The statement you write here, but I will continue the question somewhere here now, because why? I will continue somewhere this side. Want space now. So, I told all the statement, you better write it. Now start. Continued. See, I am not removed everything. This I removed. Continued. See, I will continue here. Don't see this one. This I am not rubbing because for next question, I have to change the numbers here. Advantage for me. But you have to write every time. So, therefore, your XU, how much came? 174.95 is more than XU max. XU max is 155.025. So cross section is over reinforced. I talked so much about over reinforced section. Now if somebody tells not clear means I cannot tell anything. So anyway, personal note. This actually is confidential. Somebody may be laughing. If they laugh, I will tell you laugh, and then finally you get confused. When I give a personal note, it has got to value. There is a reason for it. As usual, less means less, equal means equal, but more means equal. We got more. Therefore, now this XU will be cancelled. This is valid. So that you write here. Now one statement. This is for personal note. This is a real statement. You are right always. Whenever you get over reinforced section, I told one statement required. I don't know what I wrote last time, but the meaning is same. Ultimate MR of over reinforced section is limited to that of for a balanced section, that is for XU equal to XU max. Therefore, right here, for all further calculation, you take XU equal to XU max. Value of, now, this is the value of XU. See. Now see correctly. We started our trial with the XU equal to, I rubbed it now, I will make a note here. Our trial start, see, I don't know where. Our trial 1, you make it, you write there. You write some note here. Some note here. Our trial 1, for getting FSC, we started XU equal to XU max or equal to 155.025. And finally, we got once again XU equal to 155.025. Therefore, value of XU we got at the end of trial 1 is same as initially assumed value. We got 155.025, initially same. You are very, very lucky. You write there. Very, very lucky. Of course, question set by me. Unlucky will come later. Okay. Therefore, assumed value, personal note, trial and error over. You can write also. No more trial and error. Now if you continue once again, same thing will keep on repeating. So, note, final confirmation. Therefore, XU equal to 155.025 and corresponding FSC equal to 217.39 Newton per mm square. Now, last step. I will remove all this one now. See, not required. Okay, I will start last step I will do here. Now to calculate ultimate MR. See. Okay, this also not required. This also not required. Okay. Last closing part. Now, lastly, to get ultimate MR, that is MU, right here. If you use basic equation, MU equal to 0.36 into FCK into B into XU into D minus 0.42 XU plus FSC into ASC into D minus D dash. Substitute equal to. This is a basic equation. Equal to 0.36 into FCK is 20, B is 300, XU is 155.025 into bracket D 292.5 minus 0.42 into XU 155.025 plus FSC here 217.39 into ASC 226.19 into D 292.5 minus D dash 46. Calculate, it will come 10 to the power 6 Newton millimeter. Write the answer. I got the answer 98.26 10 to the power 6. This I calculate so that I can save the time. Okay. Now, I will rub and write once again now to save the time. Or, right, once again, or. Suppose you go for IS code version, then, see, this will remain same. This will change over to, write correctly once again. Your MU equal to 0.36 into XU by D into 1 minus 0.42 XU by D into BD square into FCK plus same. Now, before you substitute, see, we got XU. We require, see, write a note here. Before substituting, we require XU by D little higher accuracy. But here not required because our XU is 155.025. That is actually XU max. So your XU by D is 100% equal to XU max by D. Therefore, you can tell directly XU by D equal to 0.53. Or if you are that much eager, calculate XU by D. Somebody will be laughing. Equal to XU, where is the value? 155.025 divided by 292.5. I will not do it. It will come 0.53. Okay. Now, substitute and get MU. I will not substitute, I will tell here. 0.36 into 0.53 into 1 minus 0.42 into 0.53 into 300 into 292.5 square into 20 plus 217.39 into 226.19 into 292.5 minus 46. I will calculate now. See, I will calculate this way. Why calculate? If it is not coming same, then what I am telling in the class concept is wrong. Where is the answer? I rubbed the answer. I know the answer. 98.26 10 to the power 6 Newton millimeter. That is 98.26 kilonewton meter. Okay. Now you can make a note. Now suppose they ask you what is the load permitted on the beam, or what is the some unknown is given, then you equate this MR to maximum BM. Or if they want to check the safety, find what is the maximum BM for factored load. Compare it with the MR. If the BM is lesser, safe. If BM is more, exceeds, unsafe. That we covered earlier. Maybe a little later, I may include some question here. That is outside the scope of this course. My course is only to find ultimate MR. That all extra I may consider, may not consider. Okay. Now, lastly I will tell. See, if you want to thoroughly understand and get maximum knowledge from my class, you have to go through every class and understand and write everything and understand everything. Then only it will be clear. And one more thing, in my class, there is no doubt clearing, because I will tell, if someone will ask, sir, if doubt comes, will you clear? I will tell no. Some people get a little upset. This person is not clearing doubt means. Then I will tell, doubts to be cleared, if at all you get the doubt, you be regular, punctual, dedicated. Let me see how you get the doubt. First of all, so far, in around 40 years' time, nobody in the class asked me any doubt. Maybe technical doubt they will ask. Sir, some concept doubt, okay. But as far as this procedure is concerned, or solving problem, or other things, so far not a single one asked doubt. If somebody is absent to the class, he will keep quiet, because he knows it is his mistake. So you don't do that mistake. Okay, we will continue in the next class, where I will go to question 1B, where you require trial and error. I will set the question that way. After finishing mild steel, we will go to the most important, that is torque steel. Thank you. We'll meet once again.